Hi everyone, this is another problem from vector and scalar. In this problem, a vector A has a magnitude 50 centimeter which create an angle 50 centimeter create an angle 30 degree with that positive x-axis, and the vector B has a magnitude 35 centimeter making an angle 110 degree with that positive x-axis. Now we have to find out resultant of these two vectors. So what would be A plus B equal? Fine, we can find out basically using the vector triangle law. So that means if we rearrange the vector or vector B over here, so then this vector A and B would be head to tail connection, then we can say that the resultant vector of this one would be towards that direction, right? So this is would be actually that vector A plus B. That should be actually in the first quadrant. That's fine. But we cannot use that graphical representation over here. We are going to solve this one using the vector component method. So that's mean I have to find out the component of vector A and B in two direction x and y axis. So that's mean I'm going to split that vector A and B in the two dimension x and y axis. So for example, if I take the projection of vector A in the direction of x, I'll find out, say, or I can draw, say this should be that vector A component. Say if I take the projection of vector A, one component will be towards that direction and another component will be towards that direction, right? So if I multiply by the unit vector of that, say for simplicity, if I say this is actually that AX component of A along to the x direction, so that's why I write which is AX as a subscript. And if I want to express as a vector, that I can write actually multiply by the only that unitary vector, right? Which would be basically a cos theta I hat, right? Why? That is actually component method, you know that. So since I can say, I can draw over here, so this is actually your vector A, it's a right angle triangle, this is your angle theta, then this is the base and this is the hypotenuse. Then cos theta we can define, so we say this is actually the x component and this is actually that y component. Then cos theta would be base, which is AX divided by A. Then we can find out that AX would be basically that A cos theta. This is actually called the component method. But the same way we can also find out that AY, because if that is the angle is theta, this is actually 90 degree, this will be 90 degree minus theta. In that case, you can find out cos of 90 degree minus theta would be AY, this is the base, divided by hypotenuse A. Then I will find out AY would be basically A sine theta, right? That's how actually we use that component of a method. So using that one, we can find out this is would be your x component of that vector A, and this is would be basically your y component of vector A. That should be basically that AY. Now I can write down this vector A, which would be AX I hat plus AY Z hat, right? I use again the vector triangle law over here. Look at this. This is the vector AXI. I should multiply by the unitary vector, and this is the vector AYZ. They are head to tail connection. Then the resultant vector would be A. Now then I can say that AXI, which is component of vector A along to the direction of x, which would be basically that a cos theta. From here you can write down, right? So that's why I write down this would be that a cos theta I hat plus a y, which is actually that a sin theta, right? I'll write down this would be that a sin theta j hat. Now I know that everything, so I know the magnitude of A, which is actually that 50 centimeter. I convert to that into the meter. It would be that 0.5 cos 30 degree, which is the angle I hat, plus 0.5 sin 30 degree z hat. Then I can find out that vector A. What would be that? It would be basically 0.43 I hat plus 0.25 j hat. This is would be that vector A. Now for the vector B, if we split that one again, so one component of vector B would be toward that direction, right? It would be basically that Bx, and one component would be toward that direction, which would be that By. We can also find out that thing using the component again. What would be that? I will write down vector B would be B cos theta I hat plus B sin theta z hat, right? I split that vector B. Then vector B's magnitude is 0.35, so I write down the 0.35 meter, and the angle is 180 degree. We'll count down the angle from always from positive x-axis, counterclockwise is positive. That's why this angle is 110 degree. I'll write down cos of 110 I hat plus 0.35 sine of 110 degree z hat. Now if you do some calculation, you will find out that this vector B would be minus 0.119 I hat plus 0.32 z hat. So this is actually that vector B. Now I'm going to add them together to find out the resultant. Now your resultant vector R would be vector A plus vector B. Unless you express this vector in terms of I and j, that means in terms of unitary vector, you cannot add them. So we have to express in terms of unit vector, otherwise we cannot add these two vectors. If you do that, that's the wrong basically. So then what would be that? I'll write down 0.43 I hat plus 0.25 z hat minus, which is the vector B, because 119 I hat plus 0.32 j hat, right? If I do that, I will find out this resultant vector would be 0.311 I hat, because 0.43 minus 0.119, that's really 0.311 I plus 0.57 j hat. So this is actually that resultant vector. Now I have to find out the magnitude and direction of this vector. I can find out, right? I know how to find out the magnitude of a vector. If a vector A we express in terms of, say that ax I hat plus ay z hat in the two-dimensional case, then we find out this is would be basically, because it's a right angle triangle, x and y component basically, So that's why we'll use that ax square and ay square. That's how we can find out the magnitude. So if you do that, then you will find out the magnitude of this vector r would be 0.311 square plus 0.57 square. If you do that, you will find out that magnitude of this one. Let me do that. 0.331 square plus 0.57 square, square root of that, that's going to 0.64. It's going to be 0.64 meter, and the angle theta, you know, when you find out the theta for this vector, which is tan inverse ay by ax, remember this is actually the vector. You will find out, say this is actually your x component, this is actually that ax I hat, and this is actually that ay z hat. Then we say that this is actually my resultant vector I, right? Sorry, a. Now we can consider this is a right angle triangle. Say this is actually your ax, and this is actually ay, and this is would be your hypotenuse. If you say this is actually the base, this angle is 90 degree, this will be the theta, and this is the hypotenuse, this is the perpendicular or adjacent, and this is actually your hypotenuse. Now I can say that the tan theta, if you define by the trigonometric definition, actually the opposite, which is actually that ay by base, which is ax, right? That's how we find out the tan theta from the ratio of this trigonometry. So then I can say that over here I can write the theta would be tan inverse 0.57 divided by 0.311. That will be give you angle will be the 61.38 degree. That will be your answer, and which is actually in the first quadrant. That we also talk about when you draw this graphically. We find out that the angle should be in the first quadrant. So that's why graphical representation actually give you the idea, which basically without doing the calculation you can predict what will be the resultant direction of this vector. So that's how actually you can find out the magnitude and the direction of this vector. Yeah, thank you very much.